Check, check. All right, check my audio real quick. I'm gonna let the beat go for a second. And we are good to go. What's up? So I have today, I've got Eric Tarr's book Hack Audio. In this, he goes through a lot of basic DSP modules. He does it in MATLAB, but it's just DSP code. So, I mean, it's pretty easy to transfer it to a JUCE project. So I think I'll go through that. I'll go through the compressor example and replace our compressor with some custom DSP code. See if it sounds better. My bedroom comp used the same exact code from this book, and I think the transients were a little better. I kind of forgot, but our compressor right now is a little too I don't know, squishy or something. I'm not sure how to say. What's up, B samples? Let me scroll over to the compressor somewhere at the end. Oh, look, I opened right to it. Okay. I don't really have a ton of room to put this book on my desk comfortably. All right, I'm gonna leave it right there. Okay, so I think the easiest thing to do, I'm gonna make a method that takes in an audio block as a argument, and then we'll do just an audio block loop of the I'm sorry, we'll make a class that has a process method that takes in an audio block. We'll do it that way so that it looks nice. So I think I'll go into our project. It's under JUCE. Yeah, demo plugins, advanced, compressor, source, and I'll make a DSP folder, and then I'll add that in to the producer project. So we'll do add existing DSP, that, and then under DSP we'll do new CPP and header, and this will be, I don't know, I think I'll say LV compressor, just so that we don't get confused with the JUCE one. Okay, so there we go. We got it. We're gonna definitely need to include the JUCE header. Like that, and then let's see if we can get it into the audio, the plugin processor. Include DSP, LV compressor, and then we'll make an instance just to see if we can get it to build. So we'll say LV compressor. No. Oh, there's not a class yet. Of course not. Okay. Let's just make a little class first. So we'll say class LV compressor. I think I'll do it like this. Do we need to inherit from anything? I don't think so. And then I guess we'll give it a constructor. LV compressor. Like that. We'll give it a private section. Then we'll go into here and we'll just implement the constructor, and I think we should be good to go. So like that, I think is good enough. Let's see if we can instantiate it. LV compressor. Okay, LV compressor module. And then let's see if it builds. What's up, Mr. Tommy? Looks like it built, so we're good. And what we'll do is we'll name all of our methods the same as the JUCE compressor, so that it's easier for us to just copy and paste the name, and all of our code should still work after. So we're going to need a couple things. We're going to need a prepare method. Prepare. I think put no except here. Is it going to autocomplete for me? Yeah. And then void process. And I think also no except I usually do for this one. Okay, and then we're going to need a couple of setters. So it's going to be void set thresh. I think, is that what it's called on the JUCE one? I want to just name them the same. Threshold, ratio, attack, and release. Okay. Threshold. Do this. Oops. So this one's release. This one is attack. This one is ratio. And then I guess I'll put these together since they're similar. Okay, so we got our constructor, we got our prepare process, and then we've got our setters. Good. So prepare, of course, is going to take in a process spec as a reference. Let's see. I don't like it when it doesn't autocomplete. Spec, and then process is going to take in an audio block. DSP. Audio block float, I guess. That's also going to be a reference. Going to be called block. And you know what? Now I'm thinking about it. I forgot. So we're going to implement the process method here in the header. And that is because the header gets passed to the translation unit, as so I'm told. And it has a better chance of optimizing stuff that's in the header. So we put our DSP in the header, it should have a better chance of getting optimized a little better. I don't know how much of a difference it really makes, but that's what people do. So now let's see. Let's go ahead and implement the methods that aren't processed and then build again and make sure it works. So we'll say this prepare. Set thresh. Set ratio. Set attack. And lastly is set release. Let's make sure that builds. Oh, I didn't put void. Of course. Anytime you do something that you think is simple and you get an error, the first thing you should think is, was I copying and pasting, and could that have affected what I did? Usually copying paste error is what happens to me. Okay, looks like it built. Cool. All right, so let's start with the setters, so that whenever we start the DSP, everything should be good to go. Yeah. So let's go into here and create some smooth values that will be our parameters. So JUCE, I think it's just in JUCE, right? Smooth value. Yeah, okay. So I'm gonna call this underscore thresh, and then do that for the rest of them. This will be ratio and attack and release. Very simple. Cool. And now what we'll do is, oh, these have to take in some arguments. So this will be a float new thresh, float new ratio, float new attack, and float new release. And let's make sure we put that here also. New ratio, new attack, and float new release. Okay, so we have to reset the smooth values before we use them. So what that looks like is here we're gonna go thresh dot reset. So we have to give it the sample rate, and remember we're getting a reference to the process spec, so we can just get the sample rate from that process spec. So we could do spec dot sample rate, and then double length in seconds. This is how long it takes to ramp between the current value and then the new value that it's moving to, and I always just put 20 milliseconds. It usually works out, so I'm just gonna do that. So that, and we basically just do that to the rest of them, and we're all good. And then the setter methods are pretty simple. All we're gonna do is set our actual parameters to what comes into the method. So we'll do thresh, and it's not equal because we have smooth value, so it's actually set target value, which is new thresh. Yep, and we just copy and paste that to the rest of them and put in what we need to put in. So ratio for this one, attack for this one, and release for this one, and then new ratio, new attack, and new release. Very simple. Okay, so we've got our reset on the smooth values. We are getting our parameters set. Very nice. Anything else right now? I'm not sure. We might need a sample rate variable. Let me just look on the DSP on this page real quick. I don't know if we need access to the sample rate. Let's see. No, I don't think we do. It's actually quite simple. And looking through this DSP, I realize he has a couple of places where he's doing some parameter smoothing himself without using a smooth value. So we'll see if we can get the logic right and avoid that since we have smooth values. So let's start. All right, so we're gonna start in this here process method. We're gonna make a block loop because we're getting in a block. So I'm just gonna pull up on my snippets right here. Block, let's see. Is that correct? I think it is. Yeah, it looks right. So yeah, I'm going to okay, I'm just gonna follow exactly what he does. I'm gonna get rid of this, and we're gonna make two expressions that represent attack and release time, and it's gonna be called alpha A and alpha R. So auto alpha A is equal to, and it's this somewhat complicated looking equation, but you know, he already wrote it for us, so let's do it. So exponent, is it going to do it for me? Yes, okay. Of negative std log of apparently 9 divided by, oh, we do need the sample rate. All right, let's get the sample rate real quick. So we're gonna do float sample rate is equal to 44,100 by default, and then we'll say sample rate is equal to spec.sample rate. Okay, cool. So divided by, it is the sample rate multiplied by our attack time. So it's attack and when we want the value, we do get next value. Oh, but it's not auto completing for me. It doesn't like something. Get next. Oh man, why is it doing this? Xcode does this thing, I guess, where whenever there's an error and it doesn't clear out, it's not going to do any auto completion for you anymore. Okay, there we go. Sample rate times attack. There we go. Get next value. There we go. Get next value. And then we're going to do the same thing for one called alpha R. So alpha R. And this one's going to be release. And all the other values are the same. Yep, all the other values are the same. And now the next line is a gain smoothing helper, but I think we can ignore that. Yeah, okay, cool. He also breaks the input into a unipolar and dB scale input. So what he does is make a variable and he calls it x uni for unipolar is equal to, and this is just the absolute value of the input. So for us, that's data sample, right? And then he also does one for dB. So it's going to be x dB is equal to, yeah. So we can use our JUCE decibels class to change to dB. Oh wait, am I doing this backwards? I think I am. All right, instead of using, let's see, actually, yeah, it's gain to decibels. It's gain to decibels. and that's going to be x uni divided by 1 apparently. Cool. So we got those. And then he does this check, which is interesting. He makes sure that there are no values of negative infinity. So what he does is if xdb is less than negative 96, xdb is equal to negative 96. Cool. I guess I can put some comments in here. Like that. Okay. Now next we've got the downwards compression. Okay, here we go. So if xdb is greater than, and it's, I'm assuming it's ratio. I just want to make sure because he uses letters and it's hard to yeah, threshold. I mean, I'm dumb. Yeah. So thresh dot get next value. Okay. So this is the downward compression. So we're gonna say, oh, there's a new. Hold up, there's a new variable that comes out of nowhere. There's a variable called gain SC all of a sudden that doesn't look like it's defined anywhere. Does that mean gain sidechain? Let me pull up my compressor and see what I did for that. Bedroom comp. Mac. Yep, that. Did I even put it in a folder by itself? Probably not. Right here, compressor. And we've got, okay, I've got gain SC. But what is that? Gain SC. Okay, gain SC right here. Does that get initialized anywhere? Nope. Okay, maybe it's just like a in-between thing. Okay, so I'll just make a variable called gain SC. I'm gonna set it equal to 0, I guess. So what we'll do is say gain SC, yep, is equal to thresh dot get next value plus, and it is the input dB minus threshold. Divided by ratio, and that's the actual compression, right? If you divide by the ratio to bring it down. So that should be good. Okay. And then we'll say else gain SC is equal to the input. Correct? Yeah. We can't, this might look like you can just say, well, why do you need an else statement? But our gain SC is defined as 0. So if we don't put this, it'll never be updated and it'll just be 0. So the gain smoothing thing actually implements the attack and release. So I think I will put that in there. So what we'll do is take this. Right here. Yeah. Yeah, okay, so I'll take this. So a couple of these things need to be defined. Need to replace these. So I need, let's see, I'm gonna need current signal, gain change, and gain smooth. Gain smooth and current signal. Let's see what that does. Oh, and I also need gain change dB. I wonder, I don't see that right here. I wonder if it was, oh, right here. Ah, and previous, yeah. Okay. That looks good. Okay. And then lastly, is this working off of a block? It is process sample. Okay, so I'm returning, right? So I'm returning gain smooth is our actual signal. Okay. So we should be able to just say Data sample is equal to gain smooth. Okay, let's see, is that all good? Okay, let's go and see if it actually works. So we'll go in here. The new one is called LV Compressor Module. So what we'll do, we'll go here, and instead of compressor module, we'll do LV compressor module, and then prepare, yes, and then process. All right, and let's see if we got anything here. So this is going to be just the block, not context replacing. Okay, build successful. Very nice. Let's see if it actually works. Okay. Ah, very cool. No sound. All right. Very nice. So let's see if I messed anything up. Let's see. Let's see. Alpha. Let's see here. I'm gonna take gain smooth previous because I just found it in his example code. I'm gonna actually put it where he puts it, which is right after here. So that's auto. I don't need float. Okay, gain smooth previous is equal to that. Okay, then uni, the absolute value, yep, dB. Okay, if dB, yep, Okay, so if greater than thresh, gain SC is equal to thresh plus dB minus thresh divided by R, yes. And if not, gain is just that, yep. And then gain change is equal to gain SC minus, yep. Okay, then gain change dB, if it's less than gain smooth previous, then gain smooth is equal to 1 minus alpha times gain change dB plus alpha A times gain smooth previous, and then else gain smooth is equal to 1 alpha R gain change plus alpha R on gain smooth. Yep. That, okay. Okay, so he does, there's another thing here. He converts to a linear amplitude scalar, and then he applies the linear amplitude to the input sample. And then he updates gain smooth previous to equal gain smooth. So I wonder if I should just take everything from here. I wonder what happens. I notice I'm not using STD right here, so I wonder what happens if I take that out. Okay. Well, what happens if I just copy and paste all of this? Right here. Okay, I don't need this. Okay. This should be, let's see, I need data sample. Right here. Don't need this. So this is thresh get next value. Cool. Let's see, alpha attack. Yeah, this is going to be attack. Ratio. And don't need that. And then what's up with the gain smooth? Don't need that. Gain smooth previous. Oh, like that. And then And this is just sample rate, right? Oh, is it not called sample rate? Yeah, it is. Oh, I misspelled it. All right, we got us a build. Okay, we've got some signal. But I don't actually hear anything. Okay, something weird's happening. And let's see, what is this returning again? Yeah, it should be gain smooth. Let's see if that made a difference. I don't know what's going on. Oh, let me check and see if, what am I doing for attack? Okay, so yeah, they're just attack and release, nothing special, not J mapping or anything like that. What about in the actual plugin? What's the range of attack and release? Is that at the bottom? What? Where's my, did I put it in another file? Oh yeah, parameters? Okay, here we go. Speed. Oh yeah, okay. This is kind of annoying, but yeah, I had made a like a 5-way knob that had like different like presets for the speed, so I'll have to go and see where that actually is. Is that what this was? Oh look, I'm doing divided by 1,000. So 2D speed values, which are here, and then divided by 1,000. Okay. Okay. So I wonder if that's what it is. So do I need to go into here? Attack divided by 1,000. And release divided by 1,000. Very strange. Okay, attack and release, and where's that actually used? Yep, attack and release, so that should be that. I mean, the only other thing I could think of, maybe I could do this. So weird. Maybe plugin doctor give us something? I don't know what's going on. I mean, it can't be this, right? Oh, let me do this. I'm gonna get rid of this DBU thing. Also, this is like a process sample method. Is there anything in the call that is actually not, let's see. process, let's see, is equal to process sample. Yeah. Let's see if that taking out that DBU thing made a difference. You know, this happened before a while back. I'm wondering, let me replace all these with float instead of smooth value. So let's do replace it with nothing. Okay, and go here, and I'll just comment these out. And then we'll say thresh is just equal to new thresh. Ratio is just equal to new ratio. And release. Okay, does that make a difference? It's like it's just getting a value of 3.8. It's getting a consistent value. Hmm. Well, this sucks. Why is it X times that? Okay, and data sample is equal to process sample data sample. Why did that make a difference? Okay, looks like it's bringing our signal down quite a bit, so maybe something in here. Gain to decibels, decibels to gain. Let's see. What if this was just a gain smooth? Still not sure why this X is here. What? What? Something's not right. Because, okay, so the reason this worked is because this is our dry input. So it's being multiplied by just a little bit of another signal that obviously isn't working. So what's the difference? This is just a mixing logic. So this should be your wet signal right here. Oh. That's what his, okay. No, that's what it says in the book. Although, okay, hold up. So in the book, this gain smooth is actually after the return, but we can't do that. So let's do auto out is equal to this. And then we'll just return out here. Does that make a difference? Let me call it output because it looks like out might be reserved for something else. That sounded kind of weird. Ah. Is this the problem? And we are calling the set methods, right? Yep, sure are. Okay. Okay, that sounds more normal. Although we got some kind of weird problem left to right. And I still feel like it has something to do with this. This doesn't make sense to me. Why are we... Well, that's what it says. Yeah, I mean, that's what it says. X times that. Just sounds funny. I also noticed that in here I was doing the way I used to do the loop. So right here, I'm doing sample then channel. Yeah. I could try it and see if it makes a difference. So we'll do, yeah, so we'll switch, so sample then channel, and then we do What's channel buffer? So, oh yeah. Oh wait, can I do this in the block loop? I don't remember. It's gonna be something like block.get. I don't think it's array of right pointers. I guess, is it channel pointer? And then, let's see. No. So this would be, I have to use the buffer. Yeah, I honestly don't think it makes a difference. So let's put it back the way it was. Okay. Data sample equal process sample. Data sample, okay. You know what I could do, because in his code he has this gain smooth is a smooth value, but it's like in the MATLAB thing, it's like lin underscore. So maybe if I just make gain smooth a smooth value, let's see here. Gain smooth, okay, and then we'll say dot reset. Oh, thanks for the follow. Spec dot. I'm just gonna put the same stuff. Spec dot sample rate right here. That, and then gain smooth dot set target value, I guess that. And we'll go here, we'll get rid of that. And let's see. Get next value. So do I need that anywhere else? Yep. I don't know what the point of this current signal thing is, but cool. Does gain smooth come up anywhere else? Doesn't look like it. Okay, I don't know if that's gonna make a difference, but get next value. I don't think it even matters the difference between putting this before or after the return. I don't think it matters. All right, let's see if that made any difference whatsoever. I think that actually messed up the let's see, 20 milliseconds. That would be 2 milliseconds. It sounded weird. It sounded like the attack was like affecting it too slowly. Like the attack was actually ramped over. Yeah, I can hear it. It's not like it's not reacting correctly. So I think we need to get rid of that. All right, let's go back to the way it was. Something about the timing doesn't sound right. Something's not right. I could have swore. Oh, did I accidentally delete that without noticing? Okay, there we go. Now it sounds like a compressor. But it sounds like the two sides are different. I guess we can look in Plugin Doctor and see what the phase response looks like. Okay, phase. The phase is flat. Okay, does that mean that okay, well, this looks correct, which I guess would lead me to believe that this says the phase is fine. So am I hearing something that's not there? I don't know. Okay, well, whatever. I think that sounds a little bit better than the JUCE one, to be honest with you. Let's go back and listen to it a little bit. So let's go up to like 8, yeah. See, like, I'm definitely hearing, I don't know if y'all can hear it, but I can definitely hear that the left and right in my headphones sound different. And I think I see it on the meter as well. So I wonder... I wonder if we would need to do anything, because the only difference now between this and my old implementation is that... Okay, yeah, you hear it too. So the difference between this and my old implementation in my bedroom compressor is that I used the audio buffer and I took in the array of right pointers and did it that way. We could, I guess we could easily check that to see if that's what it is. So let's do this. Okay, we're gonna change this to buffer. Audio buffer. Reference buffer, and then we'll go in here and we'll give it the buffer. So that shouldn't be a problem. So let's go into here and make sure everything else is fine. So this is gonna be buffer, and then it's instead of that, yeah, buffer. I get array of right pointers, and also that actually will go out of the loop, and then the sample loop is the outside. And then it is channel then sample whenever you use it, like this. What? Auto. Oh, channel. Okay, and then do I have to do anything else for the process sample part? No, I don't think so. Because this is, let's see, it's just calling, yeah, so if I go to compressor, process sample, yeah, it doesn't take in channels or anything like that. Okay, let's build that and see if that makes a difference. Okay, I think that fixed it. We got ourselves a compressor. Check that out. All right. Okay, I think it's good. Apparently, that's what it was. So, what's weird is, so I haven't used the buffer loop like that in a long time, and I've never had an issue. And as far as I know, there's no equivalent method for the audio block. So let's just go see. DSP audio block. Yeah, there's no equivalent that I can see unless I am missing it. But yeah, and I think the reason that I haven't had a problem maybe is because I'm not using a buffer audio block. I'm using context, which is how the JUCE DSP modules are set up. That could be it, because if you look at a one of the modules, so if we go into widgets, I guess if we go into compressor, it's you get an input block and an output block, and you get the number of channels and samples from the output block. I guess that makes a difference. Okay, I guess so. But yeah, I mean, it's good enough for us. It's very simple. Yeah, it should be good. The other thing we can do is we can add a mix knob. I actually didn't think about it. The DSP is easy, but we have to update the GUI. So, let's see, what do we do? GUI. I need to make another slider. So let's say comp mix dial, and we'll go ahead and put it in that vector. And then we'll also do, is there a labels one also? Yeah. Comp mix dial label. Oh wait, I forgot the ampersand. Okay, so that should be good. So we should be able to just add it in there. So let's check out our okay, so let's make our compressor group wider. So X, Y, wait, X, Y, width. Or maybe I should just, wait, sorry. Confused myself. I gotta see which dial is first. Oh, okay, so it takes up almost the entire square, so I have to move the compressor one over and widen it. Okay, so let's do that. Compressor group, the X is gonna be times JUCE live constant. It's gonna be 0.9 or something. And then we need to make it wider. So this is the X, Y, and then this is the width. Use live constant, and by default it is at 2. So let's use that. Okay, so that looks better. Okay, let's just say 0.8. And then we will, let's see, push that over. We need to widen it a bit more. 2.5 is probably good. Actually, it's kind of hard to tell. 3. It might need to be 3. Okay, let's start with that. 0.8, and I'm gonna put it in there and just leave the live constant stuff there. So we're gonna say limiter. Let's see. Here we go. We're gonna say comp mix dial dot set bounds let's say ratio dot get x plus ratio dot get width, and then it's gonna be ratio dot get y. Do we have a ratio dot get y? No. And then let's, the width and height is the dial size. Okay, let's see what that looks like. Okay, so let's move the dials over. So what we need to do is thresh. And then If I change main left, does that change everybody's position? I hope so. 0.3. Oh. It moves everything over. So, compressor group, I don't get it. Main left. Oh. Okay. Yeah, okay, so what I need to do is this. Compressor group is equal to this. So that doesn't change, and then I can move the dial around. Ah, interesting. Okay. So apparently that value didn't quite work. There we go. Okay, so that's the group. Okay, 2, 2, 5. That might work. Two, 5. Okay, and what is this? That's the edge of it. That looks about right. 3. Okay, 2, 5, 2, 5, and 3. And then we need to get the limiter part moved over. Oh, so you know what? I think all we need to do for that is take the comp mix dial and put that right here. And we might have to mess with the limiter margin, so we'll see. Yeah, okay, so let's see. Limiter margin 1.43 is what it was at. Okay. Let's make that. I mean, it's whatever. Actually, yeah, let's do 1. So we actually don't need to do anything. So limiter, where was it? Right here. Limiter margin. Get rid of limiter margin, and then let's move the compressor one again. So compressor group, that, and then let's see, thresh, main left margin, this one. Cool. All right, 2, 3, and 2, 3. What's up, Chili Dill? I like that name. All right, 1.15, good enough. And then let's hurry up and make a new parameter for our mix. So let's go up here. We're gonna say right there. Comp mix, and then we need to make our where's our parameters at? Right here. Comp mix. Looks like I accidentally left some of the X turns in here. Comp mix is equal to comp mix, and then we'll call the name comp mix as well. Let's just do compressor mix like that. So let's see, let's line these up. Oh, looks like that one's the farthest. Okay, so that we've got comp mix in there. This is comp mix ID and comp mix name, and this is gonna be 0 to 1. And by default, I guess at 1. Cool. And add our parameter. Comp mix. And we need to add a method for changing that. So we're gonna say, I think this needs to be a smooth value. Okay, so let's go here and say mix.reset. So spec.sample rate and 0.02. Okay, we're gonna need one called set mix, new mix. Oop. Okay, this is gonna be set mix. Let's see if it, yep, there it goes. And we're gonna say, oops, mix.set target value to new mix. Very nice. That, and then the actual DSP part's pretty easy. Let's see, let's make a new variable called mix. Set that equal to, okay, you start with 1 minus your mix. Okay, next value. Okay, and then you multiply that by your dry input. So for us, that's X, and then you add it to your wet input times mix. So that would be, that's the wet input, and then that's times that, and that should be it. And we should be able to just return mix. Right, let's see here. Yep, times the dry plus this. That should be good. Yeah, I've tried to do some I have a Udemy course for calculus, focusing on like differential calculus. I haven't gone through it yet. I've brushed up a lot on just basic algebra and your trig functions like sine, cosine, tangent, and stuff like that. And just from doing a lot of DSP, yeah, I've gotten a little bit of practice with some of the more basic algebra stuff that I forgot. And I think I have a little bit better intuition for turning math into code. One of the most important things probably was to brush up on mathematical symbols like big E and stuff like that, so that if you look at some, you know, some kind of paper and it doesn't give you code, it just gives you the mathematical equation, you can kind of think your way through how to change it into code. But I do need to go through that calculus course. I've been having that for over a year. I think it would help. But yeah, I haven't done too much math studying. All right, let me get this attached before we go and see if it works. Comp mix attach, and I don't remember where I put this stuff. Oh, right here. Comp mix out. That should be it. Let's see if it works. Yeah, I mean, you can really get a lot done with just algebra and your trig functions. All right. Okay, one thing I know we forgot to actually call it. Where's that here? And we gotta say LV compressor module dot set mix. And then this will be mix comp mix ID. All right, let's see if that fixes our issue. Okay, cool. Yeah. I guess we really do need a makeup gain, because I need to be able to affect the volume of the wet signal. Yeah, too bad I couldn't get it done tonight. Although that's pretty simple. I don't really need to stream that. I mean, we're pretty much done. I just need to add that and then I can release it. And everybody can download it or clone the project. You can mess around with it. I'll release it as a plugin for Mac and Windows, and that'll be it. So the rest of it is just regular. I'm going to make another variable that's like volume for this. So this will be X times this and then times another some kind of gain parameter. And that's pretty much it. Make an attachment, add it in, put the two labels on there, and then change the colors of the dials. And I think that's pretty much it. Yeah. Well, that's about it for me today. I will see y'all next time. I'll see you on Thursday. I'm guessing I can do these changes and release it before Thursday, and then we can start working on the wave shaper on Thursday. So yeah, let's do that. All right. Well, thanks everyone. Join the Discord if you're not in there. Come hang out with me. You know, be my friend. All right. I'll catch y'all next time. See you.